Okay, so suppose we consider the following example. So we have a symmetric matrix A, and the matrix is known exactly, and it has, eigenvalues that can be ordered from the from the largest to the smallest, like this. So the largest is 1004.2, and the smallest is 10 to the minus 4. And the right hand side, vector B is measured only up to 6 significant figures. So now we have a few questions. So first, why the matrix is non-singular? Well, because you know that the determinant of the matrix is just the product of all the eigenvalues. Okay, so on the products of all the eigenvalues. And you can see that the eigenvalues, the largest eigenvalues is non-zero, and the smallest eigenvalues is non-zero. So this product is positive. So the matrix is non-singular because the determinant is non-zero. So this is the results from linear algebra. And so now, what is the condition number of the matrix A in the two norm? Well, because the matrix is symmetric, okay, and so the condition number in the two norm is just absolute value of lambda max over absolute value of lambda mean. So lambda max is the maximal eigenvalue of the matrix, which is 1004.2 divided by the smallest eigenvalue, which is 0.0005. And this one, you do the calculation, it will be around 2 million. Okay. So now the third question is, what is the relative errors? What is the relative errors in the inputs A and B? Well, see, because the matrix A is known exactly, so the relative errors in the matrix A is just a machine by epsilon, and it is about 2.2 10 to the minus 16. Okay, and the relative errors in the vector B. So you see the right hand side vector B is measured up to 6 significant figures. So then what it means is the relative errors in B is just less than 0.5, 10 to the minus 6. Okay, so when you have 6 significant figures, then this one is 10 to the minus 6. So what is the relative errors in the solution of the linear system Ax equal B when you try to solve this one, say by MATLAB in the floating point system? Well, so from the theorem in the lectures, we know that the relative errors in X will be the condition number and times the relative errors in the matrix A plus the relative errors in the vector B. Okay, and now we have the condition number is 2 million. And we have the relative errors of the matrix A is 2.2 10 to the minus 16. And we have the relative errors of B is 0.5 10 to the minus 6. And now when you do the calculation, this is around 1. Okay, because this one very small, and this one multiply this one is around 1. So you have no confidence in the computed solution because the relative errors is 100%. Okay, so that's it.